Hi there, Mr. Sutton bringing you another circle lesson. In this one, as the title suggests, we are going to use properties of inscribed angles and polygons to find other angles and arcs. Just a couple definitions to get things started. When we talk about an inscribed angle, we are talking about an angle formed by two chords whose vertex is on the circle, like angle C right here. And the intercepted arc, when we talk about that, that's the arc created by the inscribed angle. So in this case, that would be minor arc AB. For your warm-up, go to this website here at GeoGebra and see if you can figure out the relationship between inscribed angles and their intercepted arcs. So here's that GeoGebra app. We have inscribed angle D, and then the arc is going to be the same as the central angle measure. BC right here is our intercepted arc. So as we adjust angle D, let's just drag this a little bit to see what happens. Clearly they're both changing. When D is about 50, arc BC is about 100. If we move D down to 40, well, now arc BC is about 80. If we stretch it back out again, when D is 80, this arc is about 160. So hopefully you're starting to see a pattern here. The measure of an inscribed angle, and this is the inscribed angle theorem, the inscribed angle is 1/2 the measure of the arc that it intercepts. So in this picture here, for example, angle C is going to be exactly half of arc AB. And then arc AB, you could say, is exactly twice whatever angle C is. In general, if this is x right here, then this over here is going to be 2x. Based on what we just went over, see if you can figure out this variable here. Alright, so the relevant fact here is that the inscribed angle is half the intercepted arc. Since our intercepted arc is going to be 170 degrees, that means x is half of that, which is to say 85 degrees. Here's another example with an inscribed angle. Pause the video and see if you can figure out the value of x. Alright, so we can say that our inscribed angle, -3 plus 14x, is going to be half of the intercepted arc of 134. So that means this stuff is going to be equal to, let's see, that's going to be 67. Adding 3 over there, and then dividing by 14, we get x equals 5. This next one is a little bit trickier. Pause the video and see if you can figure out x here. Alright, so it sure would be nice to know what this intercepted arc is. Then we could just take half of it, and that would be x. So we'll have to subtract whatever 224 plus 72 is from 360. That adds up to, let's see, 296. Take away from 360, we've got 64. So that means that x is going to be half of 64, which is 32. This problem is a little bit different than the other ones. In this one, we're given some inscribed angles, and now we want to find the actual arc measures. Pause the video and see if you can figure out y and z. So y is the easier of the two. Whenever you want the intercepted arc, you just have to double the inscribed angle for that arc. So y is just going to be 2 times 28, which is 56. And then to find z, well, notice that z is the intercepted arc for this other angle of the triangle, this inscribed angle right here. We already know 2 measures in the triangle. So let's do 180 minus whatever 28 plus 22 is. So that's 180 minus 50. That'll give us 130. Then we know that this intercepted arc is going to be twice that, so 2 times 130 gives us 260. Let's try out this next one now. So we're looking for the value of x. Now notice that angles x and p, both, if you actually follow the legs of those angles, intercept the same arc QR. We don't know what arc QR actually is, but we know that x and p have to be the same angle because they're intercepting the same arc. So based off of that, we can just set these two expressions equal to each other and solve for x. Subtracting 4x, you've got 2x on the left, 18 on the right if you add the 4, so x equals 9. For our last problem, we'll take a look at an inscribed polygon This is a polygon whose vertices are on the circle. In other words, all the angles in an inscribed polygon are inscribed angles. So how do we figure out what these angles are? Well, let's take a look at these two opposite angles, 2A and 4A. Those aren't the angle names, but we can talk about them like that. So if you look at the arc that these two angles are intercepting, this 2A angle is intercepting exactly the part of the circle over here that the 4A angle is not intercepting. And 4A is intercepting the part of the circle that the 2A angle is not intercepting. To put it another way, between these two opposite angles, and also between these other two opposite angles, you've got the entire circle intercepted. Well, guess what? The inscribed angle is half of the arc it intercepts. So if you have two inscribed angles that together intercept 360 degrees, that means together these inscribed angles have to add up to 180 degrees. To put it another way, opposite angles are supplements in an inscribed polygon. They've got to add up to 180. Okay, well, that means we can just do 2A plus 4A equals 180. So that's 6A equals 180, so A is going to be 30. And we can do the exact same thing with the B's here. 2B plus 2B equals 180, so 4B. Dividing by 4, we get B equals 45. That's it for inscribed angles and polygons. Until next time, this is Mr. Sutton signing off.